One of the key questions about Mars is its history. And a key element of history is time. How old are rocks? How much time is recorded in the rocks? How much has elapsed between different layers? And on Earth, this is usually accomplished, assessing the time, by radiometric dating. The Curiosity rover, at its first drill site, drilled into a mudstone, and about 150 milligrams of that rock was introduced into an oven, and this material was heated to a temperature that was high enough to extract argon. And argon is interesting from the point of view of dating in that one of its isotopes is produced by the decay of a very common element, potassium. So we measured the amount of argon that came out of the rock, and then using a completely independent instrument on the rover, we determined the potassium content in the rock. And when you combine the potassium concentration and the argon concentration, you wind up with the radiometric age. There were two very surprising things about the measurement that we made. The first is the radiometric age that we obtained was about 4.2 billion years. If you would ask people beforehand, what do you think this age might be? This is right in the range that they would have expected. So for the first attempt for a radiometric age on another planet, you really want the age you get to be the age people expect. And so that was a really nice thing. The other thing is we spent some time trying to calculate the uncertainty on this measurement. And at the end of that calculation, we concluded that we had determined the age to better than about 10%, which is a remarkably high precision to obtain on a radiometric age. I think this measurement is very important to me personally because it demonstrates that the kinds of techniques that I and others have used on Earth now can be applied in space. This was a very compelling measurement that the technology has moved in the direction where this could be allowed. And this opens up a lot of new avenues, not just for radiometric dating, but for other kinds of very exacting measurements.